All right, let's see what I got, Salty. Now, he didn't have any of this information up there. He might even just leave it, but why T? Why not T? Later on, he's going to be getting into Aristotle's model of force. But what is force? And he asks one of the kids out there, what was force? And he says it's the dynamics in Greek, is dynamicus or something like that. That there's a dynamics to explaining what force is. That's the word. That takes us back to some of our old theses that I had in my model for wave function and x. That they used to be interchangeable at a time for each other while throwing a ball. We could say that x was the result, or we could say that the function, the time function, was what was the ball at this case in time. And I bring that up because I'm trying to parallel my best students in terms of a thesis of the field charge of orbitals and kids and students getting in, getting used to it, and trying to figure it out. Because as a teacher, you would. In one of these graphics, the F you see does not correlate to just run speeds or just chemical reactions in Aristotle's common sense physics relative to Archimedes, where photon serves as the F, serves as the force to the example of ball in air, ball in water, ball in oil for viscosity, let's say. They would be the graphics on here that we are trying to say F equals M and A. The two examples here of actually throwing the ball and later on presenting the equation into another form that says it's easier to write it out here as a school student to understand it in one of these classical mechanic foundation that me and any cryptologist that explains what I'm about to do here was utilizing not just the Archimedes methodology, but other forms of the work that I'm going to explain this in a force that is moving as a velocity. And that velocity requires movements, moments, M numbers, Q numbers, P numbers, whatever ones that they're going to do. But in this case, we'll be primarily utilizing the F function for dynamicus and the M as movements towards variations on points, not necessarily variations on actually being able to observe the photon, in this case, the F. Either the wave function graphic of a result of somebody doing that action from the throwing the ball or the overhead, any axiom, that those two black bodies will correlate to the same distance roughly. Here I'm going to see angle. Here I am not. I'm not going to see theta as terms of an angle from this perspective, or I'm going to see theta from a perspective, but I won't here. I will just see movement and potentially a parallel, but I would have to observe it from there. And I can't necessarily observe things from all observation perspectives, right? Nobody can. So it's pretty easy that you have to break it down into other forms. A strong force, for example, or a weak force that says, can you really determine the difference here in which way they're redshift and blue shifted? Because we're going to have to dot plot that out to find out. We'll get to the right charts here. I'll dig a little bit for it in that ground. Hang on. Well, like I said, prove your work. You know, this is not just water. There are chemical tests and what is stannous chloride to determine whether there's gold in here, and that will chemically react with that system, and that is an F in motion. Very atomic level comparatively to the gravitation models of planets and celestial bodies. But from that, it's only in a form of that much hydrogen, that much helium, that much iron does that become a red supermassive giant, a yellow star, or a blue hypergiant in any terms of that ultraviolet spectrum. It's still going to classically act like that within the ranges of what that is, but the trip between a rocky body and a black hole still implies that regardless of a singularity down there, it's still a neutron star. Something is acting as that point in the body, and I can't necessarily say that this doesn't just rip the barrier between things in that way of time dilation or accelerating frames where it can be in the infinite past. And it can also be a signal from the infinite future about what that force may reference and how we have a hard time understanding that dot plot cosmetology or topology in this example. And again, this chalkboard, and as an example, the experiment, which I'm going to call out Leonard here, but only because maybe I possibly could potentially. Just let me do it as the student on this one. Take a walk on the limb for you. I do want my throwing the ball and clay. That's also another one. But essentially for us in the board factory, I'm going to have you correct a force, that there is a tallywhacker up on this that references a bishop on a chess team of the new guy, any junior apprentices, the long-term floor guy in this model, and somebody who can oversee any of those positions in any combination of on the floor or off the floor when they're supposed to drop back. But how would you know from the topology? In this case, a knight was supposed to back through this first. And isn't it true that there's a connection here of how the relationship should work as far as the tally count for the day, as far as the best dot plot for that to say that this system defines its topology? Now, again, they have names and they're people, but to that, they serve some of the same functions. Let's see if we get to the ball here. Well, we'll get back to that. Yes. Here we go. Okay, so one of the things, it doesn't matter what theory you start with, but what F is defining here is a hydrogen gambit. How to throw a ball. That is the force in motion. But it's actually not in motion at all. It's in quantum superposition right now. And it could be in any argument, but let's say I define the limit F to say graphing paper where resources in the weak force that you need here to define it from this algorithm instead of the Carl Sagan universe loaf, what is the real live feed of conducting that action. These are the things you'll need. By the end of it, this is what that setup should generally look like as far as the paper copy. When you get to the field, we're going to need, again, that clipboard or watch or tape measure. This isn't a known football field. And in terms of ragdoll physics, a 20-foot tape measure, pacing it out in units or periods or mods, is totally acceptable here for M in terms of the number given velocity. That if in an experiment like this, using a 20-foot ruler, that's pretty appropriate. A 40-foot ruler will do it in half the time if you were measuring the distance 300 feet. Time it out. We don't know that that's not really a control variable until Archimedes' common sense physics says that we've actually defined it because there was a reason. The broad strokes were done, so that's why I came back through to see if there was any grievance errors as far as the rules committee on how to find the field that to throw a ball is roughly 300 feet, about the size of a football field. Get a heavier ball, or a rock, or a system, back to the original standards. That is the fort. That is what we are dealing with right now, and that is what I'm trying to imply onto you as students. That the ball could be a pebble. I'm going to get 5 of them. Could be a rock. I'm going to get 5 of them. Fist-sized rocks. I'm going to get 5 of them. I'm going to get 5 golf balls. I'm going to get 5 basketballs. I'm going to get, or baseballs, 5 basketballs, 5 ping pong balls, 5 footballs, 5 frisbees. And we're going to throw them on that graphic across the board until we've defined some kind of dot plot. And here you can tell my projections of an early test of only doing a few of them led me to believe that the downhill slope of that graph on that form of the measurement was appropriate. Now there are other variables, but out in that field with the graphing equipment that you'll need, the force by this example, you should come to those other correlations. Let's say, for example, you wanted to actually break it down into age, gender, or any other variable that says that there was an early marker to say that the full score 1 was correlated in any kind of specific way. From that, let's see here, gotta go back up here. We're going to begin to dot different timelines. We're going to begin to interject time into this equation because technically throwing the ball, I haven't done it yet. I just knew that there was 5 balls and we were going raw distance. So there's a couple of different forces at play about why the photon can act so quantumly in the superposition. I know I'm going to need to bring it to a time and wave function, or time and frequency domain, but I'm not sure what the slope will be. I'm not sure if it'll be negative. I'm not sure if it'll be positive. I'm not sure if that correlates to the observation of IH in the environment. Does it seem like it's natural that my shoulder would start to give out, or that my run speed would start to give out after a few hours of testing this? That's a lot of balls in packed units about how many you throw and you throw into a packet. You would narrow it down to a timeline that is appropriate for the size of that container, or it's all the balls and then all the balls, clean up all the mess, which may not be the most efficient calculation to your forces. Now again, the universe is imperfect as it stands, but at what rate can we start to lose those micro variables before we start to catch a diminishing return when somebody quotes a defined model of how that's supposed to react, or how much hydrogen can be in a fuel cell before she goes critical? Things like this are what we have to ask ourselves to begin to start to idealize of what our forms need to look like. Catch you on the next one.